Okay, so today is the product rule. I believe this came up the other day. I talked a lot about intuitions and when they succeed for us or when they fail for us, right? So we're going to play a little game here. If f at x is p at x times q at x, and here's p at x, and here's q at x, you don't even actually have to have this written down if you don't want to. You can just watch. You could write it down after. So if p at x is 3x squared times q at x, which is 2x cubed, how can I simplify this? 3 times 2 is 6x to the 5th. Yes? So what's f prime? No. Well, that's not what I'm asking. What's the derivative of this? 30x to the 4th. Okay? And I'm confident in that because I use rules that I've learned from a long time ago. Back in grade 9, we did this kind of work. So this is correct. And I know how to take the derivative of a monomial like that. So this has got to be correct. So what's p prime? 6x. What's q prime? 6x squared. Okay. So, is the derivative of f, which is p times q, is it p prime times q prime? Remember, if f at x is g at x, plus h at x, then f prime is g prime plus h prime. The sum rule. That is true. And I believe our intuition would tell us that this is true. So, what does it tell us? Not true. Okay? So therefore, proving something is true is hard. Proving something isn't true is generally easy. You find one counterexample, right? So therefore, f prime at x is not equal to p prime at x times q prime at x. Okay, not true. Folks, this is like, and then but at the end of the course, sometimes you have somebody still trying to do this. And you're like, holy cow, like we've done a whole course doing product rule almost every day, and you're still just using your intuition. Never bothered to learn the actual rule. So like, you've got to learn when your intuition is wrong and when you have to learn what the actual formula is. Okay, so what is true? You want to write this part down. P prime x times q, the actual function, plus q prime x times p. So, f at x is the product of two things. P is the first, q is the second. The product rule says the derivative of a product is the derivative of the first thing times the second thing plus the derivative of the second thing times the first thing. That's usually how we think of it. derivative of the first times the second plus derivative of the second times the first. You're adding, so order doesn't really matter, I guess. But derivative of one of them times the other one original function plus derivative of the other one times the original function. So going back to our first example and using the product rule, here's my p at x. Here's my q at x. In other words, p at x, well, this is from above. I guess we already have this written down, but it's 3x squared. And q at x is 2x cubed. While you're getting used to this, you might write this down. You might identify for yourself what each part of the product is. You could even do those derivatives separately. We've already done them, so I'm not going to redo them. So, derivative of the first thing, derivative of p is 6x, times the second thing, 2x cubed. I did not take the derivative of the second thing. Plus derivative of the second thing, 6x squared, times the first thing, 3x squared. Which equals 30x to the fourth, which is what? That's what we got up here. The one we knew was right. Now we do it this way. Again, this is not a proof. We'll do the proof if we have time. But that one's right. So now you know the product rule. And now you just have to practice using it. So we're going to do a bunch of examples, a couple other little things along the way. Any questions so far? It's just a formula. There's nothing to understand yet. When you do the proof and you understand the proof, like that'll be convincing hopefully, but like it's a formula. Formulas are not things you necessarily understand. They're just the way things are. And you just learn to use them. Yep.
For all these different rules, like if we were to see a question like that, we would automatically use the product rule.
You have to identify what rules you need to use. Yeah, 100%. Very good. What's another way I could solve this? Do you know, Isha? If I gave you this question yesterday or the day before, it would be doable. What would you do? You'd have to expand it. Expanding two trinomials is not that bad, right? And then it would be a polynomial, and you take the derivative that way, and it would get you the same answer. But some of the things we do, you won't be able to expand. It'd be like x to the 18 or something like that. Like they would have huge exponents. You have to use product rule and the other rule that we're going to talk about today. Okay, so here's my p. Here's my q. This is what I said before, just for yourself, not necessarily part of your showing your work. You might off to the side determine what the derivative of each of those is. Okay. So I'm just taking the derivative of p, which is 5x squared plus 3x minus 7. So 10x plus 3. Did everybody catch that? People are madly scrambling writing, which is fine. Derivative of q, 6x squared minus 16x. Okay? Now I come back over here and I go f prime equals p prime, derivative of the first, times the second, which is just q, 2x cubed minus 8x squared minus 5, plus derivative of the second, 6x squared minus 16x, times the first, 5x squared plus 3x minus 7. Is that okay? This is kind of what's called first line only. You'd stop there. If this were a question on the quiz, you'd stop. Okay? Questions? Yep.
How would you know if it's differentiable?
Why wouldn't it be differentiable? Did we just take the derivative of it? It's differentiable. That's a good question, Hamad. It's a very good question, and it's one you'll understand even better later in the course. There will come a time where you'll be able to recognize, I mean, with some practice, you'll just know. But like, there'll come a time where you'll be able to see where you can and can't take the derivative of a function, or whether you can or can't. Every question I give you is going to be differentiable. I'm not going to give you something that you can't take the derivative of. But this is just a polynomial. I could expand it as polynomials. So all polynomials are differentiable everywhere, right? So nothing weird about this. There won't be any questions where you can't take their derivative. I'm going to do this two ways. What's the derivative of the first thing? Thank you. 3 times the second thing. What's the derivative of the second thing? 4 times the first thing. What if I wanted to simplify this fully? What if that was the expectation? Or what if I was doing something with it where it was in my interest to have a more simplified expression? So I would get 12x minus 15 plus 12x plus 28, 24x plus 13. Or what if I expanded this first? Because binomial multiplication is something I'm pretty good at. So 3x times 4x is 12x squared. 3x times negative 5 is negative 15. 7 times 4 is 28. So this is plus 13x minus 35. Y prime is 24x plus 13. Ha! Same thing. Same thing. Which way's easier? Wrong. Which way's easier? Huh? Wrong. This is an individual thing. This is up to you and what you like better. Huh? Yes, don't do it all. No, like sometimes there's a more efficient way and there's a right way to do it that's going to save you a lot of time, and that's what you're coming to terms with, especially right now in this unit. But sometimes both are fine. Okay? Sometimes either way is fine. It kind of depends on what you're doing. It depends on what you're good at. Okay? So, both are fine. If you got this question on a test, you could do it either way. Unless it said like use the product rule to take the derivative, right? Then you would always have to do it the way that you've been told. How are we going to take the derivative of this? Expand, I like it.
Could you rewrite that as 2 times the derivative of it times the function? That's 3x plus 5. 3x plus 5. Won't the derivative and actual p-value be the same?
No, they won't. Yeah, sort of, yes. You're on the right track. Interesting thought. We'll keep that in mind.
I would just do, like, take the bracket and put 2 of it, so then you have P and Q, just the same.
So we could do that, right? And then if I was taking the derivative of this, derivative of the first thing is 3 times the second thing. This is what you were saying, right, Nasir? You get the same thing twice, so you just do that. And then plus derivative of the second thing, well, it's 3 again, and then 3x plus 5, which gives you 6. 3x plus 5s, and I could expand that if I wanted to or needed to or whatever. Again, that's a viable way of doing it. No problem. Hold on. Or you could have expanded the whole thing and taken the derivative of the resulting sort of polynomial in polynomial form. But there's something called power of a function rule. What is power of a function rule? If it was a power of 2, you might be able to do it those other ways you were thinking. If it's a power of 10, what would you have to do? Lots of those things. This might be a bit harder. What's the power of a function rule? You know what? No, not quite. So power of a function rule is n q at x to the n minus 1 then what do you think? Anybody have a guess? Times the derivative of q prime. So you do this part the same way you would do x to the third. Bring the 3 down, x stays the same, subtract 1 from the exponent. The difference is now I have something in brackets that you have to take the derivative of. So I multiply it by that. So watch. See again with power of a function rule.
So this was like similar to like just the power rule, except now it's like q and x.
Yes. You gotta go. Yep. Okay, so power of a function rule is one that we're going to see a lot as well when you have some expression that has an exponent on it. Everybody good with that? Okay. So see if you can use power of a function rule to take the derivative of this. I wouldn't want to expand this. 3x to the minus 7 to the 4, so 3x minus 7 times itself 4 times. Certainly wouldn't want to expand that. So this is where, obviously, the best strategy is to use power of a function rule. Sometimes the strategy might be up to you, and both are about the same, depending on what you're better at. If you're good at mental math, or if you're not good at mental math, then whichever one requires less work on the calculator, I don't know. But sometimes there's a clear winner. Yep. Where to get what? Derivative of what's inside. Right? Derivative of 3x minus 7. Good. Yep.
Can you keep going, like with the 3x minus 7?
So what do you mean by that?
Can you make it into 2 and then do it again? Like how would you go again?
You mean take the derivative of this?
Yeah.
Yeah. That's a thing that we will do in the next unit. We might even touch on it a little bit in this unit. We'll see if we have time. It's called the second derivative. This is the first derivative. Take the second derivative. Can you take the third derivative? Sure. You can keep taking derivatives as long as you want, I guess. Eventually, you're going to end up with 0. But you could keep going. And then it's a matter of what do the derivatives tell us about the function? Like, why would you take the derivative again? But if you kept going, you'd be taking the derivative again, right? You wouldn't just go equals 12 times 3 is 36 and keep going like this, right? Because this isn't equal to that. This is equal to the second derivative. Yeah, good question. Quadratic inside a square root. How are we going to do this one?
You change it and go into bracket.
Write it in exponential form. So I brought the exponent down. This is 1/2, right? Exponent of 1/2, so I brought it down out front. Function stays the same. Subtract 1, so to the negative 1/2. Times the derivative of what's inside. Well, what's the derivative of what's inside? 6x minus 2. And generally, we'd clean this up a little bit. If when you get a question like this on the quiz, yes, you have to take care of this negative exponent. What does that look like? This is like 6x minus 2 over 1, right? So it's going to be 6x minus 2 over 2. 3x squared minus 2x plus 7 to the positive 1/2. Negative exponent brings it down here. Then I think you'd be done. But there will come a time where we'd have to take it further. So, I mean, you could factor a 2 out of the top, couldn't you? And it would end up looking like that, fully factored. There may be questions in the practice that are factored, even though we're not necessarily saying you have to right now. But if your answer looks different, think about that. We might be factoring and simplifying a little bit further in the solutions or in the answers.
So on the test, if you don't write factor, then we can leave it as space.
Yeah, so on Tuesday, we're going to start talking about simplifying fully. And if it says simplify fully, you have to factor and further simplify. If it says first line only, then you don't. Questions? We good? Got a few more to do. Okay. Uh-oh. I'm lost. Is that it? Yeah. What do I have here? P and Q, I've got product rule. But what else? Zara? Power of a function rule for both of them because I've got exponents out there. So like we have to do both. Okay? And this is one of those ones where you may slow yourself down and go P, Q, P prime is 4, 5x plus 7 to the 3. Times the derivative of what's inside, which is 5. And then Q. Bring the 5 down out front. 2x minus 9 to the 4 times the derivative of what's inside, which is 2. Ready to go? Y prime is P prime times Q thank you plus Q prime times P. Now watch carefully. This is the last type of simplifying that you need to do for the quiz on Wednesday. And you will notice all of the answers, all of the solutions will be like this. This is what we call monomial simplification. I've got a 4 here and a 5 here. Those have to be put together. 5 and 2. But that would be finished. So when it doesn't say simplify fully, you probably have one line where you're cleaning things up. Cleaning up monomials, cleaning up negative exponents. But that's all you have to do. This can be simplified a lot further. But we're not doing that yet. Good? One more. 2 more. 1 more and then 1 more. So PQ P prime is 35x to the 4. So that's to the 1/3, right? Which makes Q prime 1/3 x to the 4th minus 1 to the negative 2/3 times derivative of what's inside? 4x to the 3. Very nice. Are you ready to go? Derivative of the first times the second plus derivative of the second, which is 1/3 x to the 4th minus 1 to the negative 2/3 times 4x to the 3 times the first thing. Are you starting to see what I mean by the algebra starts to get a little long? How can we clean this up? Well, I've got negative exponent over here, and I've got a bunch of monomials to tidy up. I'm going to do it in 2 steps. You could write this back, I suppose, as times cube root of x to the 4 minus 1. However you want to write it, that won't matter. This looks like 4 times 7, which is 28, times 1/3, which is 28 over 3. And x cubed times x to the 5th, x to the 8. That's tidying up monomials. That includes not just the numbers, the x's as well. Do you see that? So I multiply this times this and this because those are the monomials that are in this part. 4 times 7 is 28, so 28 over 3. X cubed times x to the 5th is x to the 8. But then I still have this part. Hasn't disappeared. All it takes is from this line to this line, dropping the negative, and then you get a mistake. Right? Whoops. 35, so I'll do one more. So this is going to be 28x to the 8 over 3 cube root x to the 4 minus 1 all squared. Bottom number in the exponent, the denominator of the exponent is your root level, and the numerator of your exponent is your power level. Yep.
So we just left that as 2/3, but in the denominator as a positive fraction for the exponent. Is that fine?
Yeah, you don't have to rewrite in radical form. Okay, one more thing. We're going to do this quickly. I don't even want to do the example of this because it's silly, but I might leave it for you to try. This is not something we do a lot of, so don't worry too much about it. But there is some in the practice, I believe, and it's a good way of seeing the extension of these product rules. I don't even know if this is official name or if we came up with this or what, like extended product rule, but maybe it's called that. And I'm going to write it out the sloppy way. If F equals P times Q times R, then F prime is P prime times Q times R plus Q prime times P times R plus what? P times Q, Q times P, same thing. Yes, very good. So you already get the pattern. That's all there is to it, right? It's just that's the pattern. You take the derivative of each one individually and multiply by all the others. So you could extend this up to product of 4 things or 5 things or 6 things. It would be a lot of work. It would be a lot of on your page, but the idea behind it you can extend. Any questions?
I
So there's one to try. The solution will be up, scanned in the classroom. I'm going to stop there. If we have a chance, maybe I'll throw it up at the very end of class. But I'm going to pause there.
And you said we're generally